There we go.
You're good to go, Joan.
Cool, thank you. We're live?
Yep.
Yes, sir.
Wonderful. Thank you. All right, so here we go. Welcome everyone to this webinar. I'm so delighted to see people from all over the world. I've seen so far people from Bangkok, USA, or else Poland also. I don't know, many places. So it's so exciting to see that. So let me do a quick introduction to the speaker. So our invited guest, Santiago, is Santiago Sanchez Martinez. He's currently working as a brewmaster at Fábrica de CruzCampo, which is the innovation center of CruzCampo brand and Heineken company. So Santiago, he studied biology at the Complutense University of Madrid and later the master's degree at the School of Beer and Malt, which is in Madrid, right, Yago?
Yep.
And later he worked in three different craft breweries, microbreweries to be specific, and one industrial beer factory before he started his career at Heineken. So within the beer sector, he's really passionate about the R&D of new recipes, brewing techniques, as well as the use of new yeast strains, like the Lallemand ones, I will say, to obtain different profiles and continuous improvement in the process. So just a bit of the context. I'm so happy to do this webinar with Santiago. And just for your information, we did one recently at the EBC in Lille with a colleague of Santiago, Irene, in Spanish, where she presented the same topic, and it was really well accepted by the audience, meaning that there's a huge interest, not in the craft, but in all the brewing industry, about the potential of cost saving by selecting the proper yeast strain. So, Iago, I'm not going to extend myself. The floor is yours. Thank you so much.
Thank you, Joan. Hello, everyone. I also see that you're coming from every part of the world. So, well, we're going to talk about a little study that we did in between last year and this year, in which we talked about energy saving in fermentation of 4 different varieties of yeasts, okay? 2 ale and 2 lager yeasts. As John told, I'm Santiago Sanchez. Here you got my email in case of that you want to contact me or maybe ask any questions that we don't resolve today. Also, I work for CruzCampo. It's a big brand, a big beer brand here in Spain that belongs to Heineken. And I work actually right now. I'm settled in Malaga, in Spain. Okay. So we're going to discuss different points of the study. First of all, we're going to talk a little bit of the company's context, because you'll see that Heineken has a lot of ways of making the world a little bit better, being more sustainable. Okay. And then we'll start making a little presentation of the place where the study was driven. Okay, the place where I work is the factory we have in Malaga from CruzCampo, and then we'll start to discuss the data that we got with the process, and also there was a little organoleptic profile at the end of the study, just to see a little some differences between the yeasts that we used. That were the 4 of them were Lallemand yeasts. And finally, we'll get to the conclusions, and we'll have some time to make questions and answers. Okay. So, first of all, company's context. as I told you, CruzCampo is a big brand inside of Heineken. Heineken has some pillars in the way of working and thinking. And one of those, as a very important one, is that we believe in the joy of true togetherness. The sustainability for the future is very important. With that, we have been brewing beer for more than 20 and 120 years. And here in Spain, we have 4 industrial breweries, okay, 4 factories that are settled in Sevilla, Valencia, Madrid, and Jaén. But we have also 2 microbreweries, okay, that one is settled in Sevilla, and the other one is the one that I worked in, that is in Malaga. Those 2 places are very special because they are places that we make very different things. Okay, that's why those are microbreweries. Heineken wants to work in the end with those pillars that I told you about. First of all, there's a zero emission production. Okay, in the part of production, Heineken wants to be a zero emission and actually we can compare it to 2018 when we had some amount of emissions, and now we have 100% less, because here in Spain we have all the factories working with 2 thermal energy plants, okay, solar plants. We don't make any emissions. Also, we want to work with zero CO2 emissions that we have reduced a lot from 2018 also. And we care also about water, because we use just 2.6 liters of water for every liter of beer. So every liter counts in the end, you know. Also, we try to make no wastes. Okay, so talking about, for example, plastics or on the packaging or so. And also we try to manage things like the young talent. Okay, we try to, for example, there are some benefits that we get from the microbreweries from Sevilla and Malaga, but specifically in Sevilla, there's some kind of things that we do with the earnings for young people. Okay, I'll talk about it a little bit later, but it's pretty easy. And finally, we care also, we're responsible about consumption. So we try to develop new products with less alcohol for this reason, and also the market demands it. Okay, so with all of that, we can see that in the emissions, there are some parts that get more emissions than others. Okay, we can see here in the graphic, and this study was made specifically for the part of cooling. Okay, so as we can see in this graphic, cooling was at 12% of the emissions back in 2018. Okay, and now we have a lower emissions, but we still think that this part is very important. That's the main reason that we did this study, because you can try to fix a lot of parts of the cooling system, because you have cooling system since the beginning of the in the part of the production, and also in the part of cooling the beer in the bars. So this study was made specifically for the part of production, and we did it with comparing different yeasts and fermentation. So for this, we used Lallemand yeasts for different varieties, and as I told you at the beginning, we used 2 ale yeasts and 2 lager yeasts. Okay, so the place where we did this study was the factory in Malaga, the microbrewery. This place is a place that we do innovation studies. All the time we're brewing new beers, different styles of beers, and we can sell it directly to the people, because we have also a tap room incorporated in the factory. Okay. So we try all the time new products, new ingredients, and this was a perfect place for making this study in that sense, because we have also the capability of making a lot of different beers very quickly. I mean, because of the consumption of the product in the tap room. So we all the time brew new beers very quickly. Okay. Also, the other microbrewery is the one in Sevilla that is called Factoría. And this one is the one that I told you that we use the benefits from the beer that is sold in the tap room, because we use the benefits to promote young people in a scholar course that we do here in Factoría, that is about hospitality. So the place where we do in Malaga, we use a program for automating the system of the brewing. Okay, so we just need to put inside the program all the recipe that we're going to brew, and it does it by itself, more or less. There are some parts that are a bit more physical, but in general, it's automated. We can always change some things during the process, okay, but it's everything automated with valves and so, okay. For this recipe, we wanted to use a very basic wort, so we did just a wort with a Pilsner malt, okay, and also a little bit of hops for the bitterness. The equipment that we used makes more or less about 500 liters, 550 liters of wort. So that's why we used 125 kilos of Pilsner and just 260 grams of hops for the bitterness. We did 2 different worts, because we did a wort for both the lagers and another wort for both the ages. The worts were exactly the same, but we used one wort for 2 beers and another wort for another 2 beers. Okay, and there was a separate time of brewing. The ale yeasts were used in 2023, in May of 2023, and the lager yeasts were used in March of this year, 2024. Okay, so as you can see, we did one batch for each type of yeast. And we used exactly the same ingredients, but with different yeasts. Okay, so we got more or less the same amount of gravity, original gravity, but there's a slight difference because of the different times of making the product. Okay, because one was in March, another one was in May. The temperatures are not exactly the same. And also there are some little varieties in the measurements because of the equipment that we used for the measurements. There are about 0.5 more or less degrees in the gravity. We used the same process for brewing the wort. We started with just a little amount of low temperatures for protein, for the protein part, but in the end it's a very standard scale. Okay, So basically, we did a simple maceration of that carried about 5 minutes at 55 degrees Celsius, and then 35 minutes on 62 degrees, 25 minutes in 67, and 72 degrees during 20 minutes, more or less, okay? The mash out was at 88 degrees Celsius, and then we got all the mix to the filter tank. For the filtration, the equipment automatically performs the washes, and we did the 5 sparging with 90 liters with a flow of about 5 kilograms per minute. So we got the first wort. Okay. To cool in the wort, we used a plate heat exchanger that works with a main water phase, which is recovered in the hot liquid tank, and another phase with glycol water. For the cooling in the temperature in the fermenters, there's a cooling jacket that used also the glycol water. The cooling equipment used was the GX 500R glycol water machine with 4 alternating impulse pumps with constant pressure control mode that the flow rate is about 7 cubic meters per hour. Okay, the yeast that we used were, by the part of the ale yeast, we used Voss yeast and Nottingham yeast. And for the part of the lager yeast, we used Nova Lager and Diamond. Every yeast was used in an amount of about 130 grams. But except the diamond yeast that we used 260 grams, okay, because it's the amount that is recommended by Lallemand. We can see that Voss yeast is a Quebec yeast, and it's a little bit faster in fermenting than Nottingham. But the aroma profile is clean, but the temperatures are also higher, which is going to be important in this study. Nottingham yeast takes a little bit longer in fermenting, but the aroma is also clean, and the temperatures are lower than the Quebec yeast. In the part of ale yeast, we use on the lager yeast, we use the Nova Lager yeast, and that is a yeast selected using breeding technologies, and does not generate the hydrogen sulfide, and also makes a low diacetyl. And in the case of the diamond yeast, the fermentation takes about in between 10 and 22 degrees and makes a clean aroma. So in the I will comment now the results obtained in the calculations made, okay, with the data that we got with our equipment. So from the first 4 worts obtained, we had the following results, both in terms of original density and final densities, final gravities. In case you don't understand, it's just the final ER. It means real extract or apparent extract, okay? And the OE is original extract, but in the end it's a gravity, okay? In case you don't understand it. We got some different parameters as the gravities and the pH and the alcohol, okay? As you can see, the parameters in general are very similar in between them. Like the Voss yeast and Nottingham yeast have almost the same pH and alcohol, and also the gravities are pretty similar, and the lager yeast are the same also. So the recipe was designed in a very simple way in order to obtain more information about the organoleptic profile of the yeast. That's why we used the ingredients that we use. The maceration curve was carried out to obtain the same fermentable sugars, and the yield of the yeast has been similar in the attenuation range, obtaining a similar gradation and therefore reducing the same amount of fermentable sugars. So in the comparison of the fermentation, we can see that there are some differences in the graphic. We can see how Voss yeast is introduced into the tank at around 41 degrees Celsius in the first hours, with a little drop in the temperature due to convection movements inside the tank. This also happens to the Nottingham yeast because the wort was introduced in the fermenter first at the first time colder than the ending. The ending was a little bit higher in temperature. So it takes a little bit of time to almost homogenize the temperature inside the fermenter. That's why it goes a little bit down. The set point was on 40 degrees Celsius for Voss yeast, but it did not get to so high. So what we measured for the energy was the opening of the valves of the coating of the fermenter. Okay, so depending on how much time it was open, it got more cold to the beer. But in the case of the Voss yeast, it wasn't necessary because it didn't get to the set point that was 40 degrees, and it just had to open at the moment of the cool cross. In the case of Nottingham strain, we can see how there are 8 cold valve openings that are concentrated in the first days of fermentation. In this case, the yeast was inoculated at around 20 degrees Celsius, which was the set point, and there was also a temperature drop approximately to 3 degrees Celsius. Also, there was a lower set point later at 18 degrees Celsius, where there are 3 more openings of the glycol for the valves. Okay, so in the case of lager yeasts, we can see that Nova lager is inoculated at a temperature below the temperature set point at 20 degrees Celsius. Fermentation takes place actively in the first 3 days, as it does not need a diacetyl rest. The temperature is not allowed to rise. The diamond strain was inoculated at around 11.5 degrees Celsius, and the active fermentation takes place more gradually. During the first 6 days, with the 16 glycol openings, it got more times opened than the Nova lager yeast, and this is also because of the amount of time of fermenting, as happened with the Voss and Nottingham yeast also. Subsequently, the set point is changed from 12 to 14 degrees Celsius to make the diacetyl rest, and the descent to cold begins with a first descent and then another final opening. With this, we can see that we got some amount of time of the openings of the valves. seeing that the amount of time is very different, especially between Diamond and Nova Lager. And the time, even though there are some differences in the amount of time of fermenting in between the Voss Lager, Voss yeast, and the Nottingham yeast, it took a very similar time in between Voss and Nottingham yeast, the openings, because in the end, Voss cheese has to go down in temperature for the cooling crush from a very high temperature in comparison to Nottingham cheese. So even though Nottingham had to open more times because of the amount of time in fermentation, the final time of the openings is pretty similar. For the energy calculations, the temperature data recorded by the equipment have been used since the conditions of the world, as well as those of the refrigeration equipment are the same. The small variations in density that may occur due to the temperature of the world can be considered negligible in the calculations, as could be compared in some studies that Heineken made before. These studies were made because they wanted to see if those oscillations of the temperature made the final data change, because they wanted to monitorize the data instead of taking some measurements, physical measurements. On the other hand, for the calculations, it's necessary to know the mass of the wort, which can with the density, we can get them with the density and volume that we already know because of this data that we got. Also, we need specific heat for the calculations, which varies with temperature, but can be considered negligible because of the small variation that undergoes. We can now we can know this because of the variations that I told you in the previous studies of Heineken. In this way, through fermentation, through the temperature variation, we can have the result of cooling energy. For both of wort cooling and aging cooling, the calculations have been made with a single temperature variation. However, in order to know the cooling energy during fermentation, it has been necessary to make a sum of the temperature variation suffered each time that the cold valve was used, obtaining the following results. As you can see, the Voss yeast needs more cooling energy to go down than the Nottingham yeast, since the fermentation has been higher, as I told you. Okay. The comparison that we can see is that in the end, the amount of energy was very different used. We had to use some how's the name, the controls. Okay, so we use as control the Nottingham yeast and the Diamond yeast. This was done because those were the ones that used more energy, so it was just because of that reason. Okay, but we can see that Voss yeast in the end takes a 15% less energy than Nottingham yeast, and Nova Lager uses almost a 12% less energy than Diamond yeast. This we can put it as, for example, 0.89 kilowatts per hour per hectoliter of this difference from the Nottingham yeast, and 0.77 kilowatts per hour for hectoliter for the Diamond yeast. To compare this with something, you can think about an electric car. For example, that the average electric car uses about 16 kilowatts hour, more or less, for every 100 kilometers. So in the end, it takes around 1 kilowatt per hour for making 6 kilometers. Okay, so you can think about a little bit about how the amount of energy that we're talking about. Okay, with all this, we made an organoleptic test that we used. We did with 14 people, okay, in Sevilla. Those were prepared people that work in the factory of Heineken in Sevilla. And we got these two graphics, okay? So we tested different aromas and different descriptors of the profile of the beers. And we got that the differences between the ale yeast was basically that both yeast is a little bit more bitter and also fruity in a sense of tropical fruits, and also more acid than Nottingham, which has a little bit more of a ester profile with red apple, also green apple and banana. For the lager part, we got that the both yeasts were very, very similar. If we had to take some differences in between them, the Nova Lager yeast is a little bit more spicy. It has a little bit more of a pepper and acid profile, and Diamond yeast has more of a fruity profile, more or less. But in the end, both were very, very neutral. And with the conclusions of this study, we can guess that, first of all, there actually were some differences between the yeast in the energy talking part. For the ale yeast, it was about 15%. For the lager yeast, was about 12% difference. We can apply this. This is important because we can apply it in the end to the not just the sustainability part, but also maybe even the economic part, because the less energy that we need, the cheaper that the costs are. Okay, we can use it to cut costs. Also, the kinetics were affected to the energy. We can see that. This will also depend on the amount of optimization that we can have in the cooling part. Okay, for example, in the test that we made, we didn't think about the part that we use in the water cooling part. We cool with glycol water, but also water. It's a double system. So the water that cools gets higher in temperature, and we reuse that water in the next brewing process. So that will be like a part that we didn't think about in the first place, but would be interesting to make another study, having and thinking more about the external parts of the process. Also, we recommend more studies about not just this kind of things, but also that are external, but also maybe using different varieties of yeast. And not just that, because we can also change the conditions of the fermentation. For example, different temperatures, maybe pressures, or whatever. So that the final beer will have different profiles depending on these characteristics, and also probably will affect the yeast fermentation. And it will be interesting to know if that also changes significantly the amount of energy that is used. Also, it will be interesting to have more information about the organoleptic part that we did, because we just used some amount of descriptors, but it will be interesting to make it a little bit more of an intense study about it. That was more or less the study. So now we have a little bit amount of time for the questions and answers that I hope that are already done by you. You can start making any questions that you have. So first of all, Greg asks, do any of your calculations reflect water usage and loss during the bottling, preparation, and process? No, okay, because here in this factory, there's no bottling or barreling. We just put the beer in a final beer tank, like a bright beer tank, because it's already connected to the taps. So we do not bottle the beer, so that will be like an extra part of the process that will also depend a lot on the equipment that is used, and the external temperatures, and that kind of things. Here, for example, as we're in a factory that also has a tap room, temperatures don't vary with the night, and so because it's all the time with a temperature control. Another question made by David: did you recover CO2 and/or measure CO2 output? Oh, no, because also this factory is a very small factory, and we lack of some things that maybe in an industrial factory you can find and are very common. But here it's a little bit difficult because we have a very limited space, and also the amount of money that needs. It's something that right now we don't have. So we have a very nice factory here, as it's a 5 liters factory, but well, that will be pretty nice in the future to get, but not by now. Okay. Next question by Adrian Serrano. Do you use the same time for cold crash? Compare those with other strain. Should the refrigeration equipment be sized for the specific cold requirement, which is greater in the Voss variety of cold crash? Thanks. So the time of cold crash, it wasn't exactly the same, because in the end, as the temperatures were different depending on the set point that the yeast needed, it came from different temperatures, so the time can be a little bit longer or shorter depending on how high the temperature is. Should the refrigerant equipment be sized for the specific cold requirement? Well, in the end, the cold crash was made all with the same machine. So depending, I don't know if maybe you use some kind of specific machine for baked yeast, post yeast, but we use it exactly the same as the rest of the strains. So there wasn't really any differences about except of the amount of temperature. because in the end also the maybe the gravity can be something important in this, but as we saw, that was negligible, so we didn't manage all that. um, Another question: were the beer offered to consumers, and what was the feedback on the experiment beers? Um, we offered the beers here in the tap room from the factory, but because of capacity reasons, we had to mix them. Okay, so we mixed the beers, the two LGs and then the two lager yeasts. We mixed them in one beer, ale beer and lager beer. So the feedback was a little bit more. Not as exact as we would like to know from the consumers. But if we have the option of making more studies about it, probably we'll try to see if for separate are there some differences between those yeasts used. Um, how long did you each yeast take to clarify and conditioning? Um, as I told before, it depended on the yeast used, but more or less it takes about 1 day or so to making the cool crush. It's not like very fast, but because of it's programmed to be in a way that is not too strong, but it's all the time making with the valve open. So in the end, the part that is important in the study is that the valve was open, because it doesn't have like the middle point opened. It's or opened or closed. So in the end, the important part was the amount of time of the valve being opened. Do you anticipate similar results if fermenting at higher gravity? That would be a very good question, but I don't really know, because in the end, if the gravity is higher, maybe it takes more time to ferment the yeast, or not time, but energy. In the end, is more sugar that has to be transformed. So the amount of heat should be higher, and in the end, it will mean that the yeast needs more energy for being cooled down to stay in the same amount of temperature. I don't know if
Yeah.
Joan has anything to tell about all these questions.
No, I was just saying that yeah, yeah, I mean you just replied well. Of course, if there is high gravity brewing, that will mean more cooling requirements for sure. Yeah, but as Santiago mentioned at the very beginning, this is just a small part of experiment. So we encourage the brewers here in the room, like if you wanna explore this potential, not just for this strain, but other strains that potentially require less cooling. I mean, this is something we're kind of discovering now uh, all together. So it's very exciting to see. Yeah, I'm not
Yeah,
sure
it
if
will be nice to make more studies about it, because I'm sure
mm,
that every case is going to be a little bit different in this aspect. So it will be very nice to have a study of, if we can, every gist, to
yeah,
know this aspect of every gist in the time
mm,
that we want to use it, because it's an important data that we have at the moment that we have to think of about the recipe that we're going to make. So maybe if I'm going to get a very similar profile, I can go for the one that is more sustainable, or if I actually need to be more economic in my recipe.
all right. Yeah. I just want to make a quick point here. I remember it's not on the professional side, but on the homebrewing side. I remember a couple of homebrewers from Spain. They contact me saying, "Hey Juan, I tried Kevag yeast and Voss in not just a pale ale, but something a bit strong. It was an imperial stout, both cases, and it was nice to see that the fermentation took just 2 days for an imperial stout. Initial gravity starting point was, if I remember well, 1095 in one of them. I don't remember the other one, but it went from 1095 SG down to 1020 something like that in
Mhm.
a couple of days, 48 hours. And I asked the home brewer, and how was the sensory profile? And he said, well, it's just clean. I mean the the main contribution that is coming from the malt, like all the roasty and caramel like flavors. So it was nice to see that you can ferment super quick big beers in short time,
Mhm.
apart from all this sustainable or cost
Mhm.
saving aspect.
Mhm.
So yeah,
Yeah.
it's there is a lot to experiment. I'm just trying to
Mhm.
say.
Yeah, also the clarifying part will be also an interesting part because depending on the gist, maybe the time that it takes the clarifying is a little bit longer or shorter. But the problem with that is that you have to be careful on the amount of clarify that you're looking for. Because, for example, here that we don't need to clarify because we sell everything here in the tap room, and people know what that they're coming to. Hazy beers in the end. So that wasn't anything that we needed to measure. And also, probably we would need some equipment that we don't have to measure that haziness. But it would be also an interesting part to know because that can be also an important point on the final energy consumed.
Absolutely. Yeah. Hmm. I don't know if there are any more questions out there. Otherwise, we can leave it here.
Mhm. Yep.
Adrian
Do you
has
have
a
any more
question.
questions?
Adrian says, I used to ferment 21 Plato, and usually in 4 days fermentation is finished.
Uh,
Yeah,
yeah, but you mean with the vast gist?
I guess
Yeah,
he
that's
mentioned,
the amount more or less that is
right.
for the. I think it's 4 days for the vast gist.
Yeah. And I understand, Adrian, that the fermentation temperature was 35, 38,
Mhm.
40.
Yeah, so
Just
that
wanted
the
to
amount of
confirm
time
that.
maybe is more or less the same, but the amount of energy is not because it has to cool down more.
Mm, yeah. So, again, Santiago, thank you very much for your
Hmm.
time, yourself, and also Irene.
Hmm.
It's been wonderful this project. It's been some time so far. So working together has been just awesome. So thank you for that,
Hmm.
and thanks everyone for coming to this webinar. You can shoot an email to Santiago or also the email account we have here in the chat, brewing@lallemand.com, for
Hmm.
any questions, requests, or whatever you need. Yeah. Okay. So again,
Yeah,
thanks
you can
everyone.
ask questions. Also, I think
Yeah.
it's going to be uploaded this to YouTube. So in case you want to watch it again or share, be free. And thank you very much, John, to let us make this little study because it was very fun. And I hope that we keep doing more.
Yeah. Of course. Yeah. My pleasure. Anytime. So you can see also in the chat, like the youtube.com/Lallemand Brewing, which is our account. There you will see all of course, this video, this session, but also other
Mhm.
webinars that we did in the past. So again, thank you very much, Santiago, and thanks everyone for this
Thank you.
beautiful time. Yeah. Have a good day, everyone. Cheers.